A Brief History of Time, written by Stephen Hawking, read by Mr. Narrator. Chapter 1. A well-known scientist once gave a public lecture on astronomy. He described how the Earth orbits around the Sun and how the Sun in turn orbits around the center of the vast collection of stars called our galaxy. At the end of the lecture, a little old lady at the back of the room got up and said, "What you have told us is rubbish. The world is really a flat plate supported on the back of a giant tortoise." The scientist gave a superior smile before replying, "What is the tortoise standing on?" "You are very clever, young man. You are very clever," said the old lady. "But it's turtle all the way down." Most people would find the picture of our universe as an infinite tower of tortoises rather ridiculous. But why do we think we know better? What do you know about the universe? And how do we know it? Where did the universe came from? Where is it going? Did the universe have a beginning? And if so, what happened before then? What is the nature of time? Will it ever come to an end? Can we go back in time? Recent breakthroughs in physics, made possible in part by fantastic new technologies, suggest answers to some of these questions. Someday these answers may seem as obvious to us as the Earth orbiting the Sun, or perhaps as ridiculous as the Tower of Tortoises. Only time, whatever that may be, will tell. As long ago as 340 BC, the Greek philosopher Aristotle, in his book On the Heavens, was able to put forward two good arguments for believing that the Earth was a round sphere rather than a flat plate. First, he realized that ellipses on the moon were caused by the Earth coming between the Sun and the moon. The Earth's shadow on the moon was always round, which would be truly only if the Earth was spherical. If the Earth had been a flat disk, the shadow would have to be elongated and elliptical, unless the ellipse always occurred at the time when the Sun was directly under the center of the disk. Second, the Greeks knew from their travels that the North Star appeared lower in the sky when viewed from the south than it did more northerly regions. Since the North Star lies over the North Pole, it appears to be directly above the observer at the North Pole. But to someone looking from the equator, it appears to lie just as the horizon. From the difference in apparent positions of the North Star in the Egypt and Greece, Aristotle even quoted an estimate that the distance of the Earth was 4 lakh stadia. It is not known exactly what length of a stadia was, but it may have been around 200 yards, which would make Aristotle's estimate about twice the currently accepted figure. The Greeks even had a third argument, that the Earth must be round, for why else does the first see the sails of the ship coming over the horizon, and only later the hull? Aristotle thought the Earth was stationary, and that the Sun, Moon, the planets, and the stars moved in circular orbits around the Earth. He believed this because he felt for mystical reasons that the Earth was the center of the universe, and that circular motion was the most perfect. This idea was elaborated by Ptolemy in the 2nd century AD into a complete cosmological model. The Earth stood at the center, surrounded by 8 spheres that carried the Moon, the Sun, the stars, and the 5 planets known at that time: Mercury, Venus, Mars, Jupiter, and Saturn. The planets themselves moved on similar circles attached to their respective spheres in order to account for their rather complicated observed paths in the sky. The outermost sphere carried the so-called fixed stars that lay beyond the last sphere that was never made very clear, but it certainly was not a part of mankind's observable universe. Ptolemy's model proved a reasonably accurate system for predicting the positions of heavenly bodies in the sky. But in order to predict these positions correctly, Ptolemy had to make an assumption that the moon followed a path that sometimes brought it twice as close to the earth at the other times, and that meant that his model was generally, although not universally, accepted. It was adopted by Christians church as the picture of the universe that was in accordance in scripture, for it had the great advantage that it left lots of room outside the sphere for fixed stars and heaven and hell. A simpler model, however, was proposed in 1514 by a Polish priest, Nicholas Copernicus. At first, perhaps for fear of being branded a heretic by his church, Copernicus circulated his model anonymously. His idea was that nearly the sun was stationary in the center and the other Earth's planets moved in circular orbits around the sun.